Alright. Alright, sweet. I'm just gonna wait for some people to come in. Once we have like 2 or 3 people, I'll get going, and then if more people want to join in, that's okay. Did I link the test? I did not. Okay, give me a second to do that. There we go. Okay, that's linked now. Hopefully more people will start coming in. Let's see. No one yet. Not gonna get discouraged. Okay, I think I'm just gonna get started. Yep, I'm just gonna get started. All right. Okay, we have someone in. Sweet. All right, let's get started. We're only doing the calc and stats today because that's what we asked for. What y'all asked for before. Actually, I think I'm gonna copy and paste this whole thing. Okay, so I think I'm gonna do a thing where for each problem that I do, I'm just gonna leave it up there, and that way if people have questions as I go, then I can just stop it and go back. All right, so I'm not gonna erase anything. So if you're coming here and it's a little bit later, then we're still good. Okay. Number 40 didn't take any calculus. We did that in the last one. But number 41 says, find the area bounded by the two curves shown on the right. Okay, so this is a classic just bounded area question, right? Your basic calculus bounded area question. So the first thing you have to do is you have to find the area, not the area, you have to find the equation of these two things, because you have to find the equation before you can do any calculus. Um, okay, the line seems easier just off the bat, so you can use the 2 points of the line and try to get an equation. So we got 1 point at -2, -2. Got another point at 4, 2. Okay, so we can use point slope here, and this should give us an equation, right? So slope between these 2 minus -2 over 4 minus -2. So that's 4, 6. Okay, so that's the slope of the line. This is 2/3, right? And then I'll use this bottom point just because they have positive values. So it'll be y minus 2 equals 2/3 times x minus 4. So y equals 2/3 x minus 8/3. Okay, so it should be 2/3 x minus, I don't know why I'm struggling with this. 2/3 times -4 is -8/3. Okay, yeah, so it should be 2/3 x minus 2/3. I'm gonna double check this. Yep. Yep, okay, that's right, that's right. All right, so this is the equation of our line. So we've got that covered. Now we just have to find the equation of the parabola. So there's a couple ways you can do this. It doesn't actually give us the vertex, which is a little bit annoying. But let's see, what are the coordinates of a parabola? Or what are the points that it gives us? It gives us -2, -2. It gives us 0, 4. It gives us 4, 2. So it doesn't give you the vertex, which is usually how you would solve for the equation of this. So what I'm going to do instead, I'm actually just going to use a regression, just because I think it's the easiest option. So to do a regression, you go to Menu, Statistics, Stat Calculations, and then number 6 is a quadratic regression. And then I just type in my values. So -2, 0, 4. And like there are ways to do this. I'm just trying to show you what I think would be the quickest way. Since we don't have the vertex, it's a little bit annoying. Okay, so we got that. Okay, so that's the equation of our parabola. So that's -7/12 x squared plus 11/6 x plus 4. -7/12 x squared plus 11/6 x plus 4. Okay, so these are the equations of our line and of our parabola. Then define the bounded area. The bounded area between two equations is just the integral of their difference. So we're integrating, our bounds of integration will be from -2 to 4. And then our top equation would be the parabola. Yes, so here you go. And then subtract out, the equation of the line, dx. Okay, I might have to go back and forth a little bit to figure this all the way out, but so it's from -2 to 4. Here we go. And was it 2/3 x plus 2/3 minus 2/3? Yeah. Hopefully I didn't make any arithmetic errors. Yeah. So you should get a bounded area of 21. Well, that's an answer, so I'm hopeful. Yeah. So let's go with C. Sweet. Let's move on. If no one has any questions, we're gonna move on. And if you have a question of one that I've already passed through, then just say so and I'll move back to it. Okay. Let's see. Consider the function f of x equals 1/2 cosine 2x plus 3/2 sine of x. Find the slope of the line tangent to the graph of y equals f of x when x equals pi. Okay, so this is just like a basic derivative. If you want to find the slope of the tangent line, that should like scream in your brain, oh, I'm going to use a derivative. So to find the slope at a certain point, that's basically you're taking the derivative of this equation, which you could either do by hand or with your calculator. It's up to you, whichever you think is faster. And then you're basically plugging in pi in for x. Okay, so we can do this by hand. Actually, I'll do it by hand and then I'll do it with the calculator for those of you that are less savvy. Anyway, so since we have the sum of two terms, we can take the derivative separately. So derivative 1/2 cosine 2x. So you have the 1/2 derivative of cosine is negative sine. So negative 1/2 sine of 2x. And then you have this function on the inside, so you have to remember chain rule. You got to multiply by the chain. So to multiply by the chain, you multiply by the derivative of whatever's inside, and the derivative of 2x is just 2. So instead of multiplying by 2 out here, I'm just going to say negative 1/2 times 2 is just -1. And then it's a little bit easier for the sign, so you get the 3/2, and then the derivative of sine of x is just cosine of x, and then you plug in x equals pi. So sine of 2 pi should just be 0. Yeah, sine of 2 pi is just 0. And then cosine of pi is -1 times 3/2 should give you -1.5. All right, but here's how you do that on the calculator. If if you want to know, make sure you're in radians. You can go to menu 4 and then 2 for derivative at a point. So we have x, and then our value is at pi. And then we just type in our equation. 1/2 cosine of 2x plus 3/2 times the sine of x. Yep, and you get -3/2, which is the same thing as -1.5. Yep, different way, same answer. Everything's cool. All right, let's move on to 43. So we have someone new joining us. Okay, if you wanted me to go over 41 and 42, but you missed it, you can either rewind, or if you like rewind and find out that I didn't really answer your question, just post in the comments and I'll go over it. I'm not erasing any of the work that I do for that reason. And as I'm seeing this, I'm saying we have a read sound, which could get very annoying. Okay, here is 43. All right, a balloon is rising straight up from a point on the ground 150 feet from a curious mouse. If the balloon is rising at a rate of 8 feet per second, what is the rate of change of the angle of elevation of the balloon from the mouse when the balloon is 200 feet above the ground? All right, a balloon is rising straight up from a point on the ground. Okay, so here's your balloon. I feel like balloon only has... I'm not sure. Okay, never mind. It's 150 feet from this mouse. So here's your mouse. So 150 feet. And the balloon is rising at 8 feet per second. So I don't know, you can call this, I don't know, dH/dt, I guess. The rate that your height is changing is 8. And checking the units, yeah, feet per second, feet, that's in seconds. Yep, we're all good on units. And we want to find the rate of change of the angle of elevation. So the rate of change of this angle whenever, so we want to find d theta dt when h equals 200 feet. Okay, so this is like a basic related rates problem. So you basically want to find an equation that relates all the different things in your problem, and then you basically just derive and go from there. The hardest part about this is just finding the correct equation. So I see my h is changing, so I want to include my h somehow. This down here is a constant, which is pretty nice. So I'm gonna have that 150 feet, which is a constant, but that's okay. That's okay. And my only other thing that I really care about is this angle. So we just have to find an equation that contains all three of these things. And right off the bat, I'm thinking of something trig related. So I'm thinking tangent of theta equals h divided by 150. Now, here's where the related rate comes in. If I take the derivative, or the rate of change of both sides with respect to time, well, the rate of change, or the derivative with respect to time of tangent theta, you can either have this memorized or your calculator will calculate this, is secant squared theta. Right, I'm doing d over derivative with respect to time of both sides. But since tangent theta, since it's in terms of theta, and I'm taking the derivative with respect to time, I have to multiply by, I have to use the chain rule, right? I have to multiply by this d theta dt out front. And then same thing on the right-hand side. Derivative of h over 150 should just be 1 over 150. But then remember, this is h, and I'm taking the derivative with respect to time. So I have to add, or not add, multiply by this dh dt over on the right-hand side. So do we have everything we need? Well, we're looking for d theta dt, right? What's the rate of change of the angle of elevation? We're looking for this. So we have this 150, that's a constant. We have this dh dt, it tells us it's 8 feet per second, right? Because that's the rate that height is increasing. But we don't have theta. But that's okay, because we can solve for theta, right? If you're looking at this triangle, this length is 150 feet, that's a constant. And then theta at this point, it tells us that this is when the balloon is 200 feet above the ground. So we can solve for this angle. We can use tangent. All right, and I'll say tangent theta equals 200 over 150. I solve for theta. Make sure you're in radians, by the way. I solve for theta using inverse tangent. I get that many radians. And then I want the secant squared of that for our problem. So secant of that squared gives me 2.78. Okay, so that's secant squared. So now we have everything we need. So secant squared is like 2.7778 times d theta over dt equals 1 over 150 times dHdt, which it tells us is 8. And so if we solve for d theta dt, it should be 1 over 150 times 8 divided by that, which gives us 0.0192. And it's to the nearest hundredth, so that's 0.02. Nice. That's answer choice A. Alright, as long as no one stops me, I'm just gonna keep going. Alright, 44. Ooh, we got an optimization problem here. Who doesn't love optimization problems? Actually, there's probably a lot of people that don't like optimization problems. Probably not a lot of people watching the stream that don't like them though. It's a pretty niche subset. Anyway, we have a rectangular solid with a square base, has a total surface area of 330 square inches. Okay, this is important. We have a square base and total surface area of 330 square inches. Find the maximum volume possible for such a solid. Okay, so we have to find an equation for the maximum surface area. So there's two variables that can change in this rectangular solid. There's usually three, but since it tells us it has a square base, that's going to be one factor that's not going to change. So you have two factors. One is the side length of your square, which I'm going to call it A. I'm going to call it A instead of S just because my handwriting isn't good enough to differentiate between S's and 5's. So you have A, which is the side of your square, and then you also have H, which is the height of your prism, of your solid. So what would the surface area be? So you've got the two squares on either side, so that's 2A squared. And then each of the rectangles on the sides will have area of A times H, and you have 4 of those. And altogether, that's 330. And we're okay writing 330 because that's square inches, that's cubic inches, right? Okay. So now, the reason I did that is because when you're finding the maximum volume, right, volume would be A squared times H. I'm trying to get it all in terms of one variable so that I can minimize or maximize it in order to find the maximum volume. So since H is like by itself right here, I think I'm good to solve for H. Or wait, yeah, I'm good to solve for H. So I'll say 4AH equals 330 minus 2A squared, which means that H equals 330 minus 2A squared over 4A. Nice. So, in fact, in my calculator, I might even define this just to make the math a little bit easier in the future. So x equals 330 minus 2A squared over 4A. There you go. So that means that the volume of your solid, your volume is going to be A squared times H, which now you see it's rearranged it this way. So anytime that you want to maximize or minimize something, right? Imagine you have a graph. Imagine you have a graph, and this represents the volume, right? This isn't going to be to scale, but this is just like a conceptual thing. Imagine this is the graph that represents your volume. So this is like, maybe this is the length of A, and this is your volume, right? You can see at the top here where you have your maximum, the slope of your tangent line is equal to 0. And so when you're trying to optimize something, you always take the derivative and set it equal to 0 to find out what A value this is. So here we go. Take the derivative. If you don't know about this, you can actually find derivatives by doing shift minus. I don't know. Maybe you have the muscle memory from doing menu 4-1, but I like using shift minus. So I'll take the derivative. I'll put it in here. I'll set it equal to 0 to find my A. There you go, and we get 2 A values. So obviously we're going to use the A that's positive. right? Because you can't have negative lengths. So that's the side length of our square. So let's see what it's actually asking for, the maximum volume, right? And we found out before the volume of the prism or of the solid is just a squared times h. So since I defined h earlier, you can see it's already preset for me, and I get a maximum volume of 408. 8 to the nearest tenth. 407.9. Yep, there we go. Nice. Still going. Man, these Riemann sums ones upset me. I don't like these ones. Okay, let's see. 45. Find an approximation of the area bounded by the graph 36 minus x squared and the x-axis between x equals 1 and x equals 5. Use 4 rectangles of equal width and find the height of each rectangle using the left endpoint. Okay, that's important. We're using the left endpoint. One of the rectangles is shown on the right. Okay, cool. All right, so we're going to have 4 rectangles. It tells us that. That's important. The other things that are important are the endpoints. We have x equals 1 and x equals 5. So you probably wouldn't do this on the test, but just for the sake of visualizing, I'm going to draw the other ones. So here you go. So these are your 4 rectangles. And you can see we're going to have an over approximation, but it doesn't actually ask about that, but they ask about that sometimes. Anyway, so you're trying to find the area of these 4 rectangles put together. So the way I usually do these, because I think it's the quickest way that I found, I should say, the quickest way I found is to define your function. Oh, what I meant to do. Here we go. I would define your function like this: f of x equals 36 minus x squared. And sometimes you don't have to um, because the equation is simple enough, and it just takes longer to do it this way because you can do some of it in your head. But this is like the best way I've come up with, just in general. So each of your rectangles, define the area of a rectangle, right? It's just length times height. So the width times height. The width of each of your rectangles, since it's from 1 to 5, and that's an interval of 4, and you have 4 rectangles, the width is just going to be 1 for each of them. So that means that the area of your rectangle would actually be the same thing as just the height of the left endpoint. So like for the area of this rectangle, the area would be 1 times f of 1. And then this rectangle will be 1 times f of 2, 1 times f of 3, 1 times f of 4. So I really just have to add all these together. There you go. You get 114. All right, now I must define the exact area. Well, this is a lot easier, right? This is just your basic integral. All I'm doing is integrating from 1 to 5 of 36 minus x squared, right? Integral for bounded area. That's about all there is to it. You can do shift plus for integration, by the way, if you didn't know that. There you go. You get 102.7. How specific does it want it? Tenths, let's go. 102.7. All right. Probably close to the end of the calculus. We're probably getting to the stats. Okay, yes. We only have... Oh, okay, they actually did 10 calculus, 10 stats. That's kind of nice. Okay, find the derivative of f of x if f of x equals integral from 0 to 4x of sine of t dt. All right, this is a this is an example of the second fundamental theorem of calculus, where it says if you're trying to take the integral, if you're trying to take the derivative of an integral, all you have to do is just, like, the integral and the derivative basically cancel out, and then you have to multiply by this chain. So what that would look like in this case, if f of x equals 0 to 4x of sine of t dt. This would turn, so your sign would stay the same, but inside the sign is now going to be what you have up here, right? And then you have to multiply, you have to use the chain rule to get your extra part. So you multiply by the chain of whatever's up here. And if you go like all the way through this process, you'll see why this is. This is kind of just the shortcutted way. But the derivative of 4x is just 4. And so this one's actually one of the quickest on the test if you know how to do it. That's just 4 sine of 4x. Okay, moving on. Oh, I remember this question. This question's annoying. Okay, it says 48. When evaluating x squared, or integral of x squared cosine x dx using a u substitution, the best choice for u is what? Okay, so for those of you that have taken Calc BC, you'll realize that this isn't actually a u substitution. This is integration by parts. I don't know if this is like some technicality I'm not aware of, or if this is a typo. But in reality, this is actually integration by parts. But luckily, the u stays the same. Like you still have u's in integration by parts. So the way I like to do these to find u in integration by parts, I use this acronym called LIPIT or LIPIT, whatever. And this is basically your hierarchy for choosing u's, right? You want the L. If you don't have the L, you take the I. If you don't have the I, you take the P. You just go all the way down. And this stands for logs in. I don't need to write the I again. Inverse trig, polynomials, exponentials, and trig. So you're basically just going to go down the hierarchy and see what you run into first. So do we have any logs? Well, nope, we just have x squared and cosine. So not that one. Do we have any inverse trig? Nope, no luck. Do we have any polynomials? Well, we have x squared, and so our choice is B. If it wanted, sometimes it'll also ask for dv. If it asks for dv, you just go the opposite way. So your first choice for dv would be trig, and trig we have cosine, and so your dv would be cosine x dx. It asks that pretty frequently, actually. So that's a good one to know. Also, yeah, if you're just coming in, this isn't a u substitution. This is an integration by parts. I don't know if this is like a technicality or if it's a typo, but the only way to really solve this is by integration by parts. Okay, let's keep going. Oh, we've got a Maclaurin. Well, I can show you guys a program on here. All right, let f of x equals sine x, and let p sub 5 of x be the fifth Maclaurin polynomial for f of x equals sine of x. Find the value of p of 5 of pi over 6 minus f of pi over 6. So, for those of you that don't know, a Maclaurin polynomial is basically just a way of approximating functions, right? You can in theory make a Maclaurin polynomial of pretty much anything. Yeah, pretty much anything, but it's rather useful for like sine functions, or not sine, but like periodic functions like sines and cosines and stuff like that, because sometimes whenever you're solving like differential equations and whatnot, using sine is really annoying. But if you can get like a good approximation with a polynomial, like you're about to see, then it just makes it easier to solve. Let's see. So there's really only two ways, or I guess there's a couple. You could actually calculate the Maclaurin polynomial for sine x, like right there on the test. But I wouldn't recommend that because that kind of takes a while. You could just have the Maclaurin polynomial of sine memorized, which it goes like this, and you'll see the pattern emerge pretty quickly. Right? It just goes on like this. It goes minus plus minus plus, right? Or you can use the function on your calculator, which I think is the best way because it's the quickest, and it also works if you don't have these all memorized. So here's what you do. You go to Menu, 4, all the way down to C for series, and then you'll see number 1 is for Taylor polynomial. So you type in the equation that you want to make a Taylor polynomial of, you comma x, and then you do the degree of the Maclaurin that you want. So it asks for the 5th degree polynomial, and so I'm typing 5. And so that's the 5th degree Maclaurin polynomial. You'll see it's exactly the same as what I have down here. I added the 7, but you can see, like, since 3 factorial is 6, 5 factorial is 120. Right? Yeah, it's the same thing. So we're basically trying to find the error between using pi over 6 in that equation and using pi over 6 just in the sine equation. So if I set pi over 6 to x, evaluate this, and then subtract the sine pi over 6, see we get an error of about, oh my gosh, that's really small. I'm just going to look at the last few. This goes 2, 1, 3. 2, 1, yeah, okay, so we get a lot of zeros, but whenever that happens, don't worry about it, just look right here. Yeah, and so we get answer choice A. Alright, we're doing this fast and furious, guys. Okay, last calculus one. This one, I'm not really sure what you would do if you didn't know the formula. I bet you could turn it to rectangular, but it'd be kind of tricky. Also time consuming. That's the thing with math. Like, you can know how to do every single question, and if you don't practice and you don't have the experience, then you're not going to be able to do all of them. Just because of the time constraint. Alright, it says find the length of the arc from theta equals pi over 6 to theta equals pi over 3 for the polar curve r equals 4 minus 4 cosine of theta. Alright, sweet. So to find the polar arc length, you have to use this formula. I'm not aware of anything in the calculator that will do this, so I just have this formula memorized. So it's the integral from a to b, or from alpha to beta, however you want to denote your angles, of the square root of f of theta squared plus f prime of theta squared d theta. Alright, so if your f of theta, it tells you, is 4 minus 4 cosine theta. And so that would make the derivative of that, is that just 4 sine of theta? Yeah. And so whenever you're calculating arc length, from alpha to beta would be from pi over 6 to pi over 3 of the square root of 4 minus 4 cosine theta squared plus 4 sine theta squared d theta. All right. Make sure you're in radians. I've probably said that like 12 times at this point, but it's worth saying. So I'm going from pi over 6 to pi over 3 of the square root of 4 minus 4 cosine of, yeah, I can still use x, squared plus 4 sine of x squared dx. All right, and I get an arc length of like 1.6. That should be good. Yep, that's answer choice D. We're good. We're good. Okay, moving on to the stats. Actually, I'm going to post something in the Discord letting people know that we're getting to the stats if they just wanted to catch that. Okay, let's start number 51. Actually, this is for 51 and 52, so I'm going to do it like 2 and 1. Oh, didn't mean to do that. All right, here we go. Use the table above for problems 51 and 52. It says the table shows the grades for Carolyn her first 3 years at Highland Park. Oh, I guess my brain just translated that. I guess it stands for HP. I mean, I guess it just says HP. My brain just translated it to Highland Park. Anyway, so these are your grades. So like your freshman year, this is what you got in all your classes. Your sophomore and junior. It says, what is Carolyn's cumulative average after 3 years of school? All right, so to do this, you really just have to add everything up and divide by, what is it, 6 by 3, so 18. So this is a little bit annoying, but it's easy at least. Divided by 18. And I got 95.2, or 95.17. There you go. Okay, so that one's it's a little bit annoying, but it's still easy. So it says number 52 is if Caroline needs to have a cumulative average of 95.45 or higher to graduate in the top 10, what is the minimum average required during her senior year to meet this goal? She plans to take 6 courses. Okay, so it's basically saying, so if you take 6 courses her senior year, then she'll take 24 classes. So I'm going to end up dividing by 24 in the end. So this is basically just the sum of all of her classes. So for her freshman, sophomore, and junior year, if I just multiply that average by 18, I get a sum of 1,713. And then um, plus plus the points that she would get from her senior year would be 6 times the average from her senior year. And she wants that to be greater than 95.45. Or I guess I can just set it equal to 95.45. That's okay. So we just solve this equation. Divide by 6. You get 96.3. Alright, looks like the stats is starting off a little bit easy. I bet it'll get harder though. That's okay. Alright. It says, suppose the distribution of the heights of adult males in Nevada is approximately normal. Okay, so we got a normal with a mean height of 70 and a standard deviation. Ooh, let me make this pen a little thicker so it's easy to see. All right, so we got a mean of 70 and we've got a standard deviation of 2.7. And the height of 72 corresponds, okay, it says the height of 72 corresponds to what percentile in the distribution? So it's basically saying the percentile is like if you have a normal curve, right? Here's your mean. And since that's 70, 72 is going to be somewhere around here. The percentile is going to be equal to just the area to the left of your curve, right? So we have a pretty easy way of finding the area in a normal curve. We can just use some good old normal CDF. Or yeah, CDF. So you go to statistics, distributions, normal CDF. Our lower bound is just negative infinity. Our upper bound is 72. And then what was our mean and standard deviation? 70, 70, and 2.7. Yep, so we get an area of 0.7705, which means that we're in the 77th percentile. There you go. Okay. Moving on. Oh, this is for problems 54 and 55. Okay, let me get both of these. Alright, it says use the table for problems 54 and 55. Sam was doing research for his master's thesis at Harvard. He estimated the population of an isolated group of flies 7 different times. He started at time equals 0 with 12 flies. He finished at time equals 17 with 1.58 million flies. Sam entered the list. Sen entered the times into L1 and the populations into L2 on his computer. After the following transformation equations will linearize the data. Okay. So the way that I like to do these is so you basically just have to do a linear regression and just see which one gets you the closest to linear. I'm not really sure if there's a way that you can just um, look at it and decide besides just intuition. So like I'm looking at this and I'm like, well, my populations are growing much faster than my time, and so I can probably eliminate this one. Or wait, no, I meant I can probably eliminate that one. Let me see. Yeah, yeah, I can probably eliminate that one. So pretty much, I'm either going to have to make this one bigger or this one smaller, and this one didn't do either. So B could be an option. If I increase, taking the log of L1, that doesn't work, because that's going to make that smaller. Taking the log of L2 could work. And doing the log of both, maybe, I'm not sure if that would work or not. Okay, so we kind of just have to try each of these. So, what I do, I make a list. So here's my first list. What's everything in this list? 0, 2, 5, 8, 11, 14, 17. Right, so that's one of my lists. And my other list is going to be a little more rough. 1247, 388. Actually, here we go. What did I do? Okay. 388, 3060, 24,600, 200,000, and then 1580. There you go. So we got our two lists. And now what we can do, we go to menu, 6, stat calculations, and here's our linear regression. Here's where we can see which one of these is going to work. So B would be cubing the A's, or cubing the first list, cubing A, and leaving B alone. Yeah, and leaving B alone. So here we go. A cubed and B. Let's see, oh, we get an R squared of like 0.81, so that's not very good. All right, so we try again. D is just leave A alone and take the log of B. That's another option. There we go. Okay, we get an R squared of like 0.999. So that's probably our answer. But just for the sake of practice, let's check the other one. Just because it might be cool if it's actually close. But it probably won't be. So this is the log of both of them. No, oh, that doesn't work. Oh, I know why. Because you start at time equals 0, so you can't take the log of 0. All right, so that's it. We got answer choice D. All right, it says Sam was successful in using one of these transformations listed in 54 to calculate a regression equation that fits the data. Use this equation to predict how many days after time equals 0 that the population reached 100,000 flies. So we're basically saying L1, okay, how many days after t equals 0 that the population reaches 100,000? Okay. All right, I mean, that's really what it is. Let's see. So this is really the equation that we had, and we see it's stored in F3. Stored in F3, so we're good. So F3 of x, okay. There you go. That's F3 of x. So whenever you plug in x, that's just your normal value. But whatever you get outputted, you have to remember, since we changed it this way, whenever you input x, you don't get y, you actually get the log of y. So when we want to find when it's 100,000 flies, you get the solver, F3 of our time actually is the log of 100,000. Wait, was it 100,000? Yeah, 100,000. And you get 13.05. I feel like I did something wrong. Oh, but that's okay. So our time is in weeks. Our answer is in days. Just times 7. So 91.1 days. There you go. That's answer choice B. All right, we're in the home stretch. We only got 6 more. Or, yeah, 6 more. Wait, 5 more. I don't know why I was struggling with that. All right, let's see. 400 students at Texas Tech were randomly selected and asked if they had worked out at the rec center by using a treadmill or an elliptical the past week. The results showed that 75, okay, so it says that 75 had worked on both, 190 worked on the treadmill, 260 had worked on the elliptical. How many did not work on either? So this seems to me like a pretty obvious use of a Venn diagram. I like using these. The three-way ones are annoying, but whenever you just have two, that's better. Okay, so 75, so this is both. This is the treadmill, this is the elliptical. 75 had worked on both. Said 190 had worked out on the treadmill, but it's not only the treadmill. So that 190 is including that 75. And so it's actually 115 that's in this box right here. And 260 had worked out on the elliptical. Remember, the same thing. That 260 includes that 75. So that's 185. So how many of the 400 students sampled had not worked out on either? Well, how many had worked out on one, the other, or both? So that's just the sum of these three. So 375 people had actually used one. I should say at least one. Right? And so how many people used none? Well, it's just 400 minus that, which is 25. Right. Almost there. All right. Amarillo Slim was playing 5-card poker. That's an interesting name. He had a full house, but lost to the dealer who had a royal flush. This is where a player has the 10, Jack, Queen, King, and Ace of the same suit. Slim thought the dealer was cheating because the probability of being dealt a royal flush from a standard deck of 52 cards is only what? To 9 decimal places. But yeah, you kind of just ignore the zeros at that point when there's so many. Okay, so probability, right? It's just the number of successes divided by the total number of outcomes. Well, how many different ways can you get a royal flush? Well, if you get one for one suit, there's only one possibility because like the hearts, right? The hearts only have 1 10, 1 Jack, 1 Queen, 1 King, 1 Ace, right? So there's only a total of 4 royal flushes that are even possible, right? You have one for each suit. Well, but how many different hands can you be dealt? Well, there's 52 cards in a deck, and it says it's 5-card poker, so you're dealt 5 hands. I'm sorry, 5 cards. And so in the bottom, the total number of possible outcomes would be 52, choose 5. And so when you evaluate this, you should get like a really small number. 4 on top, 52, choose 5. You get like I'm just looking at the end, 154 or 1539. Yep, there we go. That's answer choice A. All right, assume that Luka Doncic makes 35.3% of his three-point shots, regardless of the opponent or where the game is being played. He is unaffected by previous attempts. If he attempts 10 three-point shots in a game, what is the probability that he makes 4, 5, or 6 of those shots? Okay, so the probability that he makes one is 0.353, and he attempts 10 shots. You basically want to find out what's the probability that he makes 4, 5, or 6 shots. Okay, this is a kind of distribution in statistics. It's called a binomial distribution. And the reason that it's called that is for each event, there's 2 possibilities. Either you have a success or you have a failure. In this case, the success would be making a shot, and the failure would be missing the shot, right? So this is called a binomial distribution. And because you're trying to find a range of values, you're going to use a distribution called the binomial CDF, where the C stands for cumulative. It stands for cumulative distribution function. And for a lot of for a lot of stats, the only way to really do these is through your calculator. But if you go to statistics, distributions, And then just out of sight is binomial CDF. If you have it memorized, you can just click the B. I was just trying to show you. So we have 10 trials because you shoot 10 shots. Probability of making one is 0.353. And you want to know the probability of making 4, 5, or 6 shots. So your lower bound would be 4, upper bound would be 6. And that gives you a probability of 46.7%. Yep, so that's answer choice C. Okay, 2 left. Alright, a survey asked a random sample of 500 US teenagers whether music from the 1970s is superior to music from the 2020s. Okay. Of the sample, 312 responded with yes. Construct a 95% confidence interval for the proportion of US teenagers who would say yes if asked this question. Okay. So this is what we know. We know they sampled 500 people. How many successes did we have? We had 312 successes. And the yeses are considered successes because that's what we're measuring. We want to see what proportion of U.S. teenagers would say yes. So we're trying to create a confidence interval for the proportion. And so the kind of distribution you're going to use, it's called a one prop, right? We have one proportion, and it's a z interval. So to get to there, look, you go to menu, 6, distributions, right? We're using this a lot. And wait, actually no, we're trying to do a confidence interval. That's what it asks for, confidence interval. And so you can see right here, we have a one prop z interval. So we had, was it 312? Yes, 312 successes, 500 people sampled, and what level of confidence do we have? I think it was 95. Yes, construct a 95% confidence interval. And so you just click it, you just click OK, and here's our confidence interval. So it's from 0.582 to 0.666. 0.58. There we go. Pretty straightforward. You just have to know to use this interval is the only thing. And then finally, the last problem. Last problem on this test, and we'll have gone over every question on here. Okay, the average lifetime of battery packs for the Williams electric vehicle was 4.9 years in 2004. In 2012, they introduced a new battery pack that they believed would last longer. Okay, so here's our null hypothesis. It's 4.9, and they're saying that they think that they'll last longer. So we're trying to see, is our new mean greater than our old mean, or is our new mean greater than 4.9? All right, in 2012, they introduced a new battery pack that they believed would last longer. A simple random sample of 50 of the 2012 vehicles, so we have 50 of those, was selected. The mean lifetime of the battery pack turned out to be 5.1 years. But that's not a population mean, right? This is a sample mean. Turned out to be 5.1 years with a standard deviation of 0.86. An appropriate test was performed and the resulting p-value was what? So this question is a little bit tricky just because you have to find out what kind of test to use. So there's two main tests that you use for trying to for the confidence interval of a mean like this, and it's z intervals and there's t intervals. So the difference is you use a z interval whenever you don't know what the mean is. Sorry, whenever you don't know what the standard deviation is. Sorry. Oh my gosh, let me write this down so it's not confusing. For a z interval, you know it. For a t interval, you don't know it. So, in this case, the mean lifetime of the battery packs turned out to be 5.1 years. And this is the population standard deviation. So, because this is the standard deviation of the sample and not of the population, we have to use a t-interval because we don't know the population standard deviation. We have to estimate it with our sample, right? So here's what you go to. You go to statistics, stat tests, and then number 2 is for the t-test. So go to stats, okay. All right, here's our mu naught. That's like what we assumed before. That's 4.9. Our sample mean that we calculated was 5.1. Our sample standard deviation is 0.86. And the size of our sample is 50. And this part at the end is really important. We're trying to, basically, what are we testing? We're trying to find out if the new mean is greater than the original mean. So we're going to use this one right here. So press OK, and we get a p-value of 0.0532. So that's answer choice D. So actually, because your sample is 50, there's actually this thing called the central limit theorem that says if your, sorry, not the central limit theorem. It's just a rule for using t versus z. If you have a sample size that's greater than 30, then you can actually use a z interval or a t interval. But because of the way that this question was worded, I went with a t interval, but actually I do want to check and see if you could use the z interval. So go here, z, or is it not an interval? A z test, my bad. So here we go. We're using 4.9. This was 0.8. This is 5.1. This is 50. I'm curious if this gives you the same answer. And it does not give you the same answer. That's interesting. I do wonder why that is, because there is a rule somewhere. Maybe I don't understand the rule. I need to look into that. Well, luckily that wasn't an option on that wasn't an answer choice, so that you got lucky that way. Well, anyway, that's answer choice D. Just as a rule of thumb, that was wrong, so go ahead and ignore that. But basically, you don't know the standard deviation because you calculated it from the sample. It's not the population standard deviation, you calculated it from the sample. And so that's why you would use a t-distribution. All right, or a t-test. All right, so that's about it. If you're watching this in the future, after the stream has ended, feel free to comment anyway. That's okay. I'll still get back to you. And hope you learned something. And stream's over. See ya.